So let me start by demonstrating an example for Jetpack Compose. So I have written a my app function. This is a composable function, as you can understand from seeing this annotation, that is at the rate composable. Here, just let me run the code. Don't see the code currently. I'll just demonstrating over here what it does and how it does. Okay, so there is a counter. If I do the increment, it increments the counter. If I do the decrement, it does the decrement till the value is 0. After 0, it will not do the decrement. So composable functions are pure functions, meaning they don't have any side effects. They produce the same output when called several times. If you call this function for the several times my app, it will produce the same output, but there is condition. um, uh, so why this is called, why this is pure function? Because it ensures the functions are predictable and efficient in dispatching the UI functionalities. So, but there is an exception you should remember. Launching a coroutine within this composable functions of calling external methods that can produce a side effect. So, which should be avoided or handled carefully whenever you are calling the coroutines or external functions from this composable functions. So smaller composable functions can be combined to build a complex UI. You can make use of multiple composable functions to build a complex UI. You can reuse and nest composable inside other composable. So you can write some other composable function within this my app composable function. Like, let's write it. Uh, so on button click, we will do decrement, as well as we will call another function, composable function. So let me rerun it. Oh, sorry, I didn't pass the parameter. Harry Potter. And let's rerun it. So we are passing the composable function over here. That is the text. So inside this button, we are passing the text as well. So this is not a good way to write the code, but I just wrote it to explain you. So in the previous, we were calling the calling function, and there we had annotated it with the @ composable. The function takes the parameter that was a string. Inside the function, we have another composable, that is material design library. Uh, Function provided text. The composable renders some text on our UI. So when designing our UI, we usually want to see how the UI looks without running our application. Luckily, we have previews which visualize our composable functions. We will learn about them further on. So in Jetpack Compose, we will see previews. We have @preview annotation, which generates a preview of composable function or a group of composable components inside Android Studio. So it has an interactive mode to allow us to interact with our composable function. This gives us a way to quickly visualize our design and easily make changes when needed. So this is how our another function that we called will look like with preview. Let's call maybe something easy. Let's call over here. Counter title, and let's create this function, create composable function. So it created a composable function, but we need to preview it, right? It should preview something output. You have to add the preview annotation, and let's add a so this is a preview. So counter title preview function we will write, and let's call counter title function over here, counter title. Okay, not remove this, counter title, and let's create this function, and here we will add a text. We need to pass something. We had passed here something, right? We'll pass Harry Potter, and here we will pass the string name, that is of type string, and text. In the text we will write we are reading the book dollar name, right? So let's run this code. So before that we have to include this over here. So see, here we are calling the counter title preview. We are reading the book Harry Potter. Counter title preview is the one preview function. So let's see what is a preview. So see this, we have a preview annotation to indicate that we want to build a preview for this function. We want to build a preview for this function, counter title preview over here. So we have to set the background parameter to true. Let's say show background to be true here. Background. Okay, so here we can see that which adds a white background to our preview. So it should have added the white background. Okay, let's see what might be the issue. So we have named the function with preview suffix. Here we have given the preview suffix to acknowledge that this is a preview function. So the preview is also a composable function. So this preview function is also a composable function. To be able to see the preview, you need to be in split mode or in design mode. So this is split mode and this is design mode. In your editor, so these options are normally at the top right. You see at the top right. We also need to do a build for Android Studio to generate a preview which will look like this. You have to complete the build, then it will look like this. So we have a text that displays the string that we have passed to the function. So what is the string that is passed? We are reading the book, and the string is passed from the counter title function over here. So we can show both previews for dark and as well as light color scheme. We can also configure properties such, oh, it is due to the scheme that color scheme I'm that using it. My theme is dark, so it will show the dark background over here. So previews are great for quick iteration while designing UIs. However, they are not replacement for actual device simulator testing, particularly such as animations. You should not test the animations over here as it is not convenient or it is not proper to verify. There are interactions or dynamic data. You should not verify those with the previews. With an understanding of what previews are and how to create them, let us look into one more feature, that is modifier. For the so modifier allows us to decorate our composable function by enabling the following. You can change the composable size, behavior, and appearance, add more information to them. You can process user input and add interactive interactions such as clicks or the ripple effects. So with modifiers, we can change various aspects of our composable, such as the size, padding, or the color and shape. So most Jetpack composable components from the library allow us to provide a modifier to them. And as a parameter, for example, if we need to provide padding to our preview, this text is there. So how do I add a padding? Mm, it should be something like this. Oh, I wrote modify. It should be modifier equals to modifier equals to modifier. Not, and we need padding. Padding of how much? We are giving the values in dp. So let us give it as 16 dp. 16 not dp should be there. So we have added this for padding modifier to the text composable. This will add a 16 dp padding to the text composable. So 16 dp is a density independent pixel unit in Jetpack Compose. So this is density pixel, and here we need we have to add the modifier for padding correctly. Let me correct the code. Goes to modifier dot okay. See here you can see it has added the proper padding over here, whatever the padding of 16 dB we have provided, and it has applied the material theme also over here. So you got it. This is how we are adding the previews over here. So moving on further, we have added the preview over here, and so we have added two more modifiers. Let's add two more modifiers, that is fill max width in this text, whatever the text we are passing. So over here, when you say dot padding, you can add extra things over here, like dot fill max width, and let's save it, and let's rerun the code again to see the modifier getting affected in our code. And let's give some background color as well. Dot background color we want, and let the color be red. It should be red. Capital. And let's run it again. So background color will be red, and it will take the max width over here. Yeah, you can see the background color is red. So these are the two parameters we have added. First is fill max width modifier, which is added to the text composable, that will make the text composable take the full width. So it will take the max width of the parent. See here, as we have added the padding, it has shared this 16 dp padding on the two spaces, and this is what space it has taken. So there is the background modifier to the text composable. This will add a background color to the text composable. The preview for our text will look like this. Okay. The preview will look like this, as seen in the preceding. The text now occupies the whole width of the device and has a red background. So it also has the padding of 16 dp around. So modifiers do not modify the original composable, they return a new modified instance. This ensures our composable remains unchanged and immutable. Immutability, fundamental principle in functional programming, ensures that the state remains unchanged, simplifying state management uh, and reducing side effects. This approach enhances predictability and readability by adhering to the principles of referential transparency. This ability to compose functions exemplified by chaining modifier functions facilitates a concise and readable expression of complex UI behavior without altering the original composable. Okay. In addition to using the existing modifier, we can also create our own modifiers when needed. Now that you have an understanding of what modifiers are, we're going to build on the knowledge by learning about Jetpack Compose layouts in the next section. So Jetpack Compose layouts works like something like this, has a variety of pre-built layouts to use. Before looking at the different layouts, we will see how Jetpack Compose transforms the UI. So there is a composition, we write the code, there is a composition, we define the layouts in this composition, and then it draws those UI. So this is how the composition transforms state into UI. So first there is a composition, then there is a layout, and then there is a drawing. This is what is compose transform. So from the diagram we can see that our state is transformed into the UI with the following stage. First is composition. This is initial phase. The compose compiler creates a tree of UI elements. We first of all, the compose compiler is there that creates a tree of UI elements. Each element is a function that represents a UI element. Compose then calls the function to create the UI tree. The composition step is responsible for determining while composable need update and which ones can be used. This happens by comparing a previous tree of composable with the new tree and only updating the ones that have changed. This makes this step very efficient as only elements with updates are updated. Then there is a second stage, that is layout. So we have created the UI tree, and we only update the we always compare with the previous tree of composables, and we only modify the changes that has to go. So this layout step happens after the composition phase. Here the composable compiler takes the tree and generated in the composition phase, whatever the tree we generated, that it takes that and determines its size and position and layout. So it determines the hierarchy. Each composable is measured and positions without the layout based on its parent. So everything is placed without based on its parent, within based on its parent, and any constraint that is set. This phase is responsible for determining the final position and size of each UI elements on the screen. So this is also responsible for creating the final layout tree used in the drawing phase. So drawing is the last phase of transforming the UI to state. In this phase, the compose compiler takes the final layout tree creates in the layout phase and uses it to draw the elements on the screen. This is done by walking through the tree and issuing draw commands to the underlying graphic system. This phase is responsible for rendering the final UI on the screen. These three phases work together to create the UI in Jetpack Compose. The composable phase builds a tree of composable, the layout phase positions and sizes them, the draw phase renders them on the screen. This entire process is optimized, uh, performant and efficient, allowing for fast and smoother UI rendering in your complex UIs. So we have got through the three phases of creating our Jetpack Compose UI. So now that we have understood how the Compose compiler renders the UI, let us see the layouts that are in Compose. Jetpack Compose offers the following layout that are column, row, box, and list. So we are going to take a look at each of these layouts in details in the further on. To begin with, let's just take a column layout. So column, we use column when we want to organize the items vertically. So whenever you want few of the things vertically, we use column. So let's remove all this stuff. Let there be nothing. Let us remove this other things as well, and let's add three text. Okay, we have already used text, so it will be easy. Let's write the name of three Valorant agent, namely Jet, and we're going to do this same, I think, multiple times. Okay. uh, Sage, then let this be Phoenix, let this be ISO. Okay, so let's run this code. So we have items, but they are not arranged vertically. So if you want something to be arranged vertically, you have to use column. This is the one, and here you have to include everything as part of this column. Now let's run the code. So see here, we have arranged them in a in a column, in a vertical column. And for adding the modifier in this code, we have to use the rounded brackets modifier equal to oh, modifier equal to modifier dot padding of how much? Let's say I'm adding only the top padding of 24 dp dot dp. Let's run the code again. So it should add the top padding over here. If you learn something, apply it in the code so you can further more understand your code properly. You can use spacer as well if you want. There is a spacer function, so that can also be used to add the okay. So this is how we create the column and add these 4 text elements in them. Adding a preview for this generates the UI for us, so you can add the preview annotation as well. So let's run it again. So here you can see it has a preview, my app, and there is a rendering problem somehow. Yeah, it has rendered properly. So this is the preview. We are going to polish it up a little bit by using the modifiers, more modifiers. Let's add the size as well. By using dot fill size. Oh, sorry, I've done it wrong. After this, I have to add the dot fill max size. Then let's add padding. Already we have added. So let's say vertical arrangement. Equal to arrange it should be not dot, it should be comma over here. Vertical arrangement equals to vertical arrangement equals to vertical arrangement equal to arrangement dot center. How do you want the vertical arrangement? You can see the other options as well. To the end, to the start, to the bottom, to the center. You want it in the center. Then let's say horizontal alignment. Alignment to alignment, not center horizontally. We want it. That means in the middle. Let's add more. Let's make it more proper. See, it is aligned horizontally in the center, and vertically also it is center arranged. So here we have added a modifier to our column. In the modifier parameter, we have specified the max size modifier, which makes our column fill the available size within the parent. This is helpful for binding full view screens on our UI. We have also the padding of 24 dp, uh, that is density pixel. uh, Additionally, we have specified two more parameters to our column, that is vertical arrangement, which is used to specify the vertical arrangement of the children of this view. In this case, we have specified align dot center, which places all the children of a column vertically at the center. The other parameter is horizontal align, which is horizontal alignment of the children in the layout. In this case, we specify the value of alignment center horizontally, which will align all the children at the center horizontally. So our preview will look like this. Where is my preview? Why the hell preview is not rendered? Okay, it is zoomed out, that's why. Zoomed in. So from the this preview, we can now see our column occupies the whole screen, and all the text elements are centered vertically and horizontally within the parent. Now let us see the row composable. So this is column composable. Mm, Let us now use row. Let us now create row. So this was the column. Let's comment it out. Let's add row over here. So row is when you want to arrange items horizontally. So let's copy the same code. I want to remove all the modifiers that we have added. And let's comment them out. So it should be row. We want to understand row, not column. This is the row. Okay. What the hell? So whenever we want to organize items horizontally, this is how you want to organize them. It should be at the red composable. Sorry, at the red composable is here. See, these things are arranged horizontally, but then again, the horizontal composable is used to display four text over here, elements horizontally in a row. So the preview is looking like this. Here you can see each element is different. So the text element are arranged next to each other in a horizontal row, but they are all different elements over here, four different text elements over here. So row, like the composable, supports the addition of modifiers. Let us modify our row to look more proper and clean. So how do we use to do it? Modifier equals to modifier, and let's apply. Fill max size. Let's add some padding in this of, let's say, 20 dp. Then we have applied the vertical why this is vertical alignment equals to alignment dot center vertically. So it is vertical alignment over here. Over there in the column it was arrangement, so here the terms changes. So alignment is done center vertically, and horizontal arrangement, horizontal arrangement. Oh, sorry, I missed comma over here. Arrangement equals to arrangement dot space evenly. So there should be evenly spaced between them. And let's run it. So here you can see there. So in the code we have added modifiers To the row composable, the fill max size modifier takes the row, fill the entire available space, as what we have done previously. uh, the padding modifier adds padding to the row. The vertical alignment and vertical horizontal arrangement modifiers are used to align the children of the row vertically and horizontally. So note that the horizontal arrangement modifier, we use the arrangement and space evenly option that makes sure each of the children are occupied equal spaces in the parent. So this preview, uh, the preview for this looks like this. Here you can see it. So the row occupies the whole screen and the text elements are evenly spaced within the screen width. So in the next part we will learn about box layout. So what is a box layout? The box layout allows us to position children elements in a flexible way using the XY coordinates. Can use the XY coordinates to place your position your child elements. So uh, yeah, let's create an example of box element. I'll comment this part out. Let's create a box. I'll copy paste the code. You should the import composable icon bitmap and once notification. Let me try this out. Okay, so in this code we have a box composable that has a icon and text composable as its children. We have, so what does it have? Box has icon and there is a text. Okay, so first is icon, this icon, and then there is a text. Alignment, vertical center, vertical. Okay, so these two composables are its children for this box composable. We have set the size of the box composable to 100 dp. Let it be 200 dp so you can see it more clearly. And the icon composable is 80 dp. So this icon is 80 dp. Let it be some more. Let it be 150 dp. The icon and the text and icon composables are placed in the center of the box composable. So this box, inside this box, this is the box. Inside this box they are placed center. Okay, in the center. over here. So moving on further, let's see. We have seen the column, we have seen the row, and we have seen the box over here. So yeah, so we have two things over here, that is icon and text. These are two composables. These are the two children to this composable, and we have to set the size of the box to be 150 dp, and we have icon to be 80 dp, not 80 dp. What was the size of the icon? It is 150, and size of the box is 200 dp. And the center of the box composable using the so this icon and text are placed in the center of the box composable using the content alignment parameter. This content alignment parameter, whatever the contents are inside the box, they will be placed in the center. So this is how they are stacked on top of each other, because the box composable is a layout composable that stacks its children on top of each other. So the preview of our box composable looks like this. Yeah, and further on, the notification icon and the text are stacked together. The box composable enables us to achieve this and much more. So now let's see, moving on further, we will see the list in Jetpack Compose. So let me comment this out. So Android developers, we need to make apps display list of items. uh, it can be a list of movies, orders, songs, or books. So how do we do that in Compose? The good news is that Android Compose makes it easier than the XML. If someone has the expertise in XML as compared to that, they can understand that Compose makes it more easy. So Compose provides lazy column and lazy row components, which can be used to display the list of items. These components are very efficient and performant. They only render the items that are visible to your screen rather than rendering all the items at once. So lazy row and lazy column displays items vertically, while lazy row displays them horizontally. Lazy column and lazy row are normally optimized for larger data sets at a time and not suitable for all use cases. So they are generally used for the larger data sets. So for all use cases, this component functions allows you to define the contents of the list as a function that returns a single element, and then Compose will automatically generate and renders the UI element on each item in the list as they become visible to the screen. So let's see example. Let's see with lazy column. So we have lazy column with 100 items. 100 items, right? So each item is a text composable. Each item will be a text composable. So let's preview this. First of all, now let's run it again. Yeah, here you can see. So as you scroll, you will see all the items are there in list till 99. So we can see that we have a list of items that scroll vertically. As mentioned, it only shows the items that can fit on the screen. If we use interactive modes on our preview, we can use interactive mode on this preview. We will be able to scroll through this. Start interactive mode. So this is my physical device. If you want to verify that without any physical device or emulator, you can verify with the preview as well. So is it not scrolling? Uh, it's nothing. Sometimes it's little difficult to understand the behavior of this previews. So so this items tells composable to create the 100 items. So it is something like this. Uh, Something like this. You can replace it over here. For it in 0 to 100, do something like this, and it should be the same behavior. uh, Now let's add it in some other composable function. No, mm, let's name us this composable as count. What was the name of this? Oh, okay. Let's create a composable function count, and here we will add this. IT, and here we will receive now. Let's try again. Let it be old one, why do I need to? So then again we have easy row. Yes, in the example of easy column we should see the example of lazy row as well. Mm, so here we can see the lazy row. So here also we have added the 100 items. Each item is a text composable. Each item is a text composable. The preview for this looks like this. Here is the preview. You can enter the interactive mode and see for yourself over here. Uh, we can see from the figure that we now have a list of items that scroll horizontally, similar to lazy column. It only shows the items that can fit on the screen. If we use the interactive mode on our preview, we can scroll through the end of the list. We also have two more type of list layout, that is lazy vertical grid and lazy horizontal grid. The two layouts are part of the lazy grids and help us arrange our content in grids. So they're commonly used in applications such as galleries, movies, and spreadsheets. So lazy vertical grid creates a vertical list of items in a grid. Uh, let's see an example of code of lazy vertical grid. So this is lazy vertical grid. We have taken the grid cells of 3, okay, and this is a vertical grid, okay, because we can scroll vertically over here. So we have used the lazy vertical grid component. We pass our modifiers. Uh, so note that we have a columns parameter over. Same modifiers are there. We only have added one more modifier, that is column parameter. This parameter is allowed to specifies the number of the column and how item grid will have a fixed number of columns or row in the uh, so and arrange within these columns. In the case of grid cells is to be fixed, so grid cell will be fixed over here. So this means that the grid will have an fixed number of columns or rows in its lazy horizontal grid. Also, we have the adaptive tab. We can use the adaptive tab, which defines a grid with as many rows and columns as possible, with the condition that every cell has a minimum size and all extra space is distributed evenly. Our preview is looking like this. This is the preview, and let's take an example of vertical horizontal grid. Let's run it. I didn't edit this. Hold and let's run again. See here, this is horizontal grid, and here also we have verified rows instead of column parameter. So vertical lazy vertical has column parameter, lazy horizontal has rows parameter. So the code is similar to lazy vertical grid, only the parameter is different over here. The only difference is we have used lazy horizontal grid, and instead of column we have passed row to describe how the cells will be in the row. So we have three rows on the entire screen. We have lazy vertical staggered grid also, and there is a lazy horizontal staggered grid also, which is remarkably similar. The only difference is that they adapt to the children's height and width, respectively, meaning they all do not have uniform height or width. They are based on the height and width of their children. So let's have a look at the constraint layout further on.